This is the 3.1 day 2 video for notes. On day 1, we just focused on how to tell if something was a function by looking at ordered pairs, a table of values, a mapping diagram, an equation, or a graph. So we talked about, the fact that functions, every x is paired with exactly one y, no x's repeat with different y's, and then we talked about that vertical line test. So today we talked about domain and range. So domain is the set of all the x values in the function, and the range is the set of all y values in a function. So the first thing that we did today is we looked at graphs. So those are the visual representations of functions, and we talked about how to tell if something was discrete and if something was continuous. So remember, discrete data is individual data points. So those are not connected. They are like something that you would list. For example, this first graph right here would be discrete because, as you can see, they are individual data points. Okay, so that would be an example of a discrete graph. Okay, so if you have a discrete graph and you're trying to find the domain and range, you're going to actually list out the points. So since domain is our x values, the first thing that you want to do is you want to look at these points that they've graphed on the graph. Okay, so this first point, the leftmost point here, the x value is -3 and the y value is -2. So you may want to make yourself a little list or something if you're trying to look at those ordered pairs. That would be, these are my x's, remember, and your y's come second in an ordered pair. So then the second point on the graph, which is right there, is at -1, 0. So you might want to write that down. It will help you write your domain and range. Then my third point, which is right here, would be at 1, 2. So x is 1, y is 2. Then my last point, which is located up here, if you go over on your x coordinate, it would be at 3 and up 4. So that point is 3, 4. Now, to find domain of a discrete set of data, you just have to list it. So we know that our domain would be equal to all the x coordinates. So that would be -3, -1, 1, and 3. And we use the little curly brackets, which don't look great here on my screen, but you know what they are. For our range, we're looking for our y values. So we are going to list them. They are -2, 0, 2, and 4. Okay? So that's for discrete data, and that's what that first one is. So now let's look at the second one. So obviously I've done 2 examples, so more than likely the second data, or the second graph, would represent continuous data. Continuous data is data that is graphed with a smooth line or curve, and so that means all those little points in between the whole numbers, so those fractions and decimals, are part of our domain and range. So when you do this one, what you want to do is you want to look at your leftmost point and your rightmost point. Okay, remember your domain is x, and that axis goes left and right. So this point right here is my leftmost point. Let me go ahead and draw a line for you guys. If you look at that point right there, you see, so let me draw a line. This is kind of fat, but I'll shift it over there. You can see that that point, the x value on it would be -2. And you can see over here that my rightmost point, its x coordinate would be 3. Okay, so my leftmost point was at -2. So this is for this one. For my domain, my leftmost point was -2, and my rightmost point was +3. So that would be the range of x values. It goes from -2 to +3. So -2 would be less than or equal to x, which would be less than or equal to 3. So when we did this, we talked about the fact that continuous data, you have to include all the little points that fall in between. For this one, -2 and 3, which means all those little decimals, and that's why we use the inequality. We worked on graphing inequalities in chapter 2, and we talked about the fact that, those included all those values. So this includes all the values from -2 to +3. Now let's go ahead and look at our range. So for our range, that's up and down. So you go from your lowest point on the graph to the highest point on the graph. Okay, so let's go ahead and draw another line here. So for this one, I'm going to start at my lowest point. So if I put my line under there, I see that the lowest y value on this graph would occur at -1. Then if I go up to the top of my graph, I see that the highest y value is 2. So the range between my y values is from -1 up to +2. So I'm also going to express that with an inequality. So from -1 less than or equal to y, which would be less than or equal to 2, would represent my range for this. Okay, so notice the difference here. Continuous data we write as an inequality using the leftmost point to the rightmost point for my domain. And for my range, I went from the lowest to the highest. Make sure you're looking at the correct axis when you're doing this. Okay, discrete data, a little bit easier. You just have to list your x values and list your y values. So this was the next example that we did on our notes. What I'd like you to do now is try to pause and see if you can go ahead and identify if it's discrete or continuous, and then write your domain and range. Okay, so for these two examples, my first one was once again discrete because it's the individual data points. In order to find my domain, I looked at each ordered pair and I listed the x-coordinate of it. So for this first point right here, the x-coordinate was at -2. Then I had one here which was at -1, 0, 1, and 2. So that's where my domain came from. I have my bracket and each of my x-coordinates separated by commas. Then for my range, notice my range was shorter, it was smaller, there was less data because this one is at 0, but these two have the same y value, and that's at 2, and then these two have the same y value of 4. Okay? For the second one, this is continuous. Notice that this is connected with a smooth curve, and I talked to you guys, I told you this was called a parabola, which we'll work on second semester. So for my x values, I went to my leftmost point, and I went down to my graph, and I noticed that the x-coordinate was at 1. My boundary on the right side, if I went down, was at 5. So 1 is less than or equal to x, which is less than or equal to 5. That means all the x-coordinates of all these points that fall on this graph would be between 1 and 5, and then also including 1 and 5. That's what these closed circles mean. For my range, this one's a little bit different because my lowest point is right here in the center of the parabola. It's called the vertex, and that actually occurs at 0. See, remember you have to go over to the y-axis. So this point, my lower boundary was 0, and my upper boundary, these two share a y value of 4. So 0 is less than or equal to y, which is less than or equal to 4. So then from that point, we moved on and we started talking about some word problems, and we introduced some more vocabulary. So notice here, they're asking me to identify the independent and dependent variables. So the independent variable, those are your x-coordinates, and that's also known as domain. Then my dependent variable, which is my y-coordinates, also known as range. So they gave me a situation here. They said the function y equals -3x plus 12 represents the amount y of juice remaining in a bottle after you take x gulps. So identifying the independent and dependent variable should be fairly easy here because they told me that y is the juice remaining. Well, the dependent variable is y. So I know that for my dependent variable, it would be the juice remaining. Okay? Then it asked me to do the independent variable as well, and right here it says after you take x gulps. So that means that your domain or your independent variable or your x coordinates would be the number of gulps that you've taken. Okay? All right. So we've answered A. We identified our independent and dependent variable from our scenario here. Remember, your y or your dependent variable depends on x. Okay, so this one is going to be affected based on what happens to x. Okay, all right, so here, they gave me a domain. They asked me to use 0, 1, 2, 3, and 4, and they asked me to find the range. So notice this is discrete, because they're calling the number of gulps. I've taken none, I've taken 1 gulp, 2 gulps, 3 gulps, 4 gulps. Okay, so I told you guys there's 2 ways you could do this. You could put this in y equals and view the table of values and go to 0, 1, 2, 3, and 4 in your graph. I mean, not on your graph, on your calculator. So that is kind of the easier way because it's all just there and the data's in one spot. So that's what I'm going to review here. So turn on your calculator and go to y equals. It's the button that's in the upper left-hand corner. And you're going to go ahead and enter the function here. So negative 3x plus 12. So I have negative 3x plus 12. I'm going to press second and table. That way I can see my table of values. And that's going to allow me to find my range. Okay? So I'm going to list my range since this is discrete data. So I'm going to 0 in my table and I see that it's paired with 12. Then I'm going to 1 in my table and I see it's paired with 9. 2 is paired with 6. 3 is paired with 3. And 4 is paired with 0. Okay. So let's say you didn't have a calculator. You didn't have a graphing calculator. What would you do? Well, they've given you an equation here. So when they are giving you a domain, what they're saying is put a 0 in for x and solve. So you could have just done, well, if y equals negative 3 times x plus 12, and they're asking you to use these numbers for x, you just substitute them into the equation. So if y equals negative 3 times 0 plus 12, well, negative 3 times 0 is 0, plus 12 is 12. That's where this 12 came from in my range. Then I could do the same thing with a 1. Well, if negative 3 times 1 plus 12, what would that equal? Well, negative 3 times 1 is negative 3, plus 12 is 9. So that's where this 9 came from. So if you don't have a graphing calculator at home, all you have to do is plug each of these numbers in for x and solve, and that gives you the range values. Okay? Because you have an equation. You know that y equals negative 3x plus 12. Okay, so this was the last one on your notes. Why don't you go ahead and pause and see if you can do that work on your own. Okay, so for this problem, they tried to be a little tricky. They didn't use x and y, but that shouldn't be a problem. You guys should be able to look at other variables and know that you can use any letter that you want. So here, they told us that the function a equals negative 4b plus 14 represents the number a of avocados you have left after making b batches of guacamole. Okay, so when I identify my independent and dependent variables, well, ask yourself, what depends on the other thing? Well, the number of avocados left depends on the number of batches of guacamole that you make. Therefore, the number of avocados left has to be your dependent variable, and the batches of guacamole you make is your independent. You also should kind of have a hint because they're giving you the function, and if a equals negative 4b plus 14, the way all of our functions have been written so far, this variable has represented our dependent variable. Now, it won't always be that way, but that's the way they've been written today. Okay? All right, so to find my range, they gave me a domain once again, so I substituted in a 0 for b. Negative 4 times b, that'd be 0 if I use 0. Negative 4 times 0 is 0, plus 14 was 14. Then plug in a 1. Negative 4 times 1 plus 14 is 10, and so on and so forth. All right, so we've spent 2 days on our first section, which is over functions. If you're having any issues or you have any questions, please come in. Don't forget to do your 3.1 homework, and I will see you guys tomorrow.